This question is asking us to find the probabilities of two event outcomes. So these events are spinning a spinner and you're flipping a coin. The spinner probabilities are listed here, and heads, of course, is going to be 50-50. And these are two independent events because the spinner, or what happens with the spinner, has no effect on the coin or anything like that. And so when you have independent events, so both those events are both outcomes are going to occur for each of the events, is going to be a multiplication. If an or, that means like either one could occur and that's going to count. That would be where you add those probabilities, but then you have to subtract the and. To help showcase that, I've made an area model. An area model is one way to represent all of the outcomes and their probabilities with a two-event probability problem. So you can see we have our spinner options and the probabilities listed, our coin options and their probabilities, and then you multiply within each of those boxes. So the probability of white and heads is going to be right here where you have the overlap of white and heads. So it's going to be 3/16. Or if you wanted to use the formula from below, you have the probability of white and you're just going to multiply by the probability of heads because they are independent, which is exactly why you're going to take your 3/8 and you multiply by your 1/2, and that's why you end up with 3/16 as your answer. Now, as far as the or problem, if you have either red or tails, so that means either red can happen or tails can happen. Doesn't matter about the other options or the other pieces of the puzzle. And so probability of red is everything that you see here in this column, right? And then you're going to have the probability of tails. So probability of tails is everything that is in this row. So all those things that are highlighted are going to count. So you could if you're using an area model, you could just take your 1/16 and add another 1/16, and then you could add 1/4 and add 3/16. So you could just add those four different outcomes, and you end up with your answer, which is going to turn into a fraction of 9/16. You can do it that way, but you could use your formula down below. And if you use your formula down below, what you have to do is you have to do the probability of red. Let's get my marker out here. So the probability of red, and you're going to add to it the probability of tails. But then what you have to do is you have to subtract that probability of red and tails. Right? Remember this notation here with that little upside down U-looking thing, excuse me, is your and representation. And so as you calculate this, if you do it by hand, using the formula, the probability of red is 1/8, and you're going to add to it the probability of tails, which is 1/2, but then you have to subtract that overlapped spot. So you can see this overlap spot of 1/16 that you have to subtract, and that is why, because we don't want to count this box twice. You see that it is highlighted twice, and so that is where that one subtraction comes from. So you take your 1/8 and you add the 1/2, but then you're going to subtract 1/16. And you end up with that same exact thing of 9/16 or 0.5625. And so that would be your answer for this one. So I'll just keep it in fraction here. So 9/16. This is the number one mistake for students. So be careful with this question with the or problem. And it's only for two event probabilities that you subtract. Now we have another or problem here. So not red or heads. So not red is going to be everything else that's not red. So let's do it with our probability formula here. So probability of red with the little prime mark means not, plus the probability of heads, and we're going to subtract the probability of not red with the little prime and heads. So to calculate that, not red would be everything else besides red. So that's going to be 7/8. So you're going to have 7/8 here. We're going to add to it 1/2. And you can see if we just stopped it right there, if you did 7/8 and you added 1/2, we would have a probability which is more than 1, which is no good, right? You can't have that much of a probability. And so that is another good explanation as to how does this actually work, this or question. You're going to subtract the overlap of those things, which is the product. So that's the probability of not red, which is 7/8 multiplied by 1/2. So we're going to take that previous answer, which is the sum, and we're going to subtract from it 7/8 multiplied by 1/2. And when you do that, you end up with your solution, something a little bit less than 1. We can convert it to a fraction, and so your answer would be 15/16. So very likely 15/16 that would happen. As if you look at this, so not red is all of these options over here, or heads would be this one here. So like all of these 5 boxes are included. The one we don't include, 1/16, which is exactly what this is missing. And finally, this last question is kind of actually a gimme if you're thinking about it. Probability of yellow and heads. So this is an and problem, which means both these things have to occur. It's probability of yellow and not heads. But the point being is that there is no yellow in this spinner. So 0% probability and something else is not possible. So your answer for this one is just 0.